Alright, kiddos, this is your last video until after Thanksgiving, so that'll give you some hope and a little outlook. We're going to talk about writing equations from two points and a table, because they really kind of go together, and once you know how to do one, you can do the other, and it all sort of flows with everything we've been doing. So far we've written equations from a graph, and we've written equations from the point-slope formula. Now we're going to write equations from 2 points and a table. We're just going to put it all together. Number one asks first for us to determine if the data is linear. In order for data in a table to be considered linear, it has to have a constant rate of change, which means its slope has to be the same throughout the table. If the slope is not the same throughout the table, then it's not linear. It will be some other kind of function. So the first thing we're going to have to do is we're going to have to find the slope, and we're going to have to find the slope between all of the points and make sure that it is constant throughout. So here's what we will do. We'll find all the change in our y's. From -2 to -3 is a change of -1. From -3 to -4.5 is a change of -1.5. This is a change of -0.5. And this is a change of -2. Now, just because these are not the same does not mean our slope will not end up being the same throughout. That's why we have to also check the x's, because we want change in y over change in x. We're going to have to make sure it stays constant throughout. So our change here is 2, then our change here is 3, then our change here is 1, and then our change here is 4. So see, these aren't constant either. So we're going to have to check all of these ratios, y over x, and make sure that they work out. So the first one is -1 over 2. That's the slope for those first 2 points. Now the slope for the next 2 points is -1.5 over 3. And if we take our calculator and we simplify that, we get that it is the same thing as -1/2 or -0.5. So they're again the same thing. So far my slope here and my slope here is the same, because this is -1/2, and then this simplifies to -1/2. So my next one is -0.5 over 1, which is the same thing, because that's -1/2, as -1/2 over 1, or just -1/2. So again, we have the same slope. So now we just have to check the last one. The last one becomes -2 over 4, and if we simplify that, it is -1/2. So no matter where I am in this table, even though it doesn't look like it's constant, my slope is -1/2. The first one is what, -1/2. The third one, the second one, the third one, and the fourth one all reduce to -1/2. And so yes, this is linear because it has a constant rate of change. The slope is the same throughout. So now let's check B. We're going to do the same thing. From 11 to 2 is a change of 9. From 2 to 18 is or -9. From 2 to 18 is a change of +16. And from 18 to 27 is going to be a change of +9. So far things aren't looking so good. I've got a negative and then 2 positives, so it's not looking like we're going to have a constant rate of change, but we'll wait. So from -3 to 0, my x's, that's going to be +3. 0 to 4 is also +4, and then 4 to 5 is +1. So let's just check our slopes. Our first slope is going to be -9 over 3, which if I simplify becomes -3. My second slope for the next place I found change is going to be 16 over 4, which is going to be 4. Well, already my slopes are not constant. We're going to check the third one just so we can see. The third one happens to be 9 over 1, which is also the same thing as 9. And so I have 3 different slopes. It goes from -3 to +4 to +9, which tells me not a constant rate of change. So no, this will not be linear. It has to have a constant rate of change. So this one is not. And so if you're asked this question, make sure you check the slopes between all of the points. Make sure they all simplify to the same number. So now we're going to use some tables to find the slope, and then we're going to use that slope and that table so that we can write an equation in slope-intercept form and standard form, because practicing that's a good idea. And so here's our table. We're going to find the slope. Change in y happens to be +5. Change in x is going to be +1. And that's the same thing here, +5 +1. So my slope is going to be 5 over 1, or just 5. So there's my slope. My y-intercept is right here because x equals 0, so y equals 11. So my b is 11. So my slope-intercept form of that equation is y equals 5x, because that's the slope, plus 11, that's the y-intercept. Now I got to put that in standard form. Well, in standard form, that means x and y are on the same side. And if I subtract 5x from both sides, because that's what I need to do to make it standard form, I would get negative 5x plus y equals 11. But if you'll remember, in standard form, this number cannot be negative. So I have to multiply the entire equation by negative 1. So I end up with 5x minus y equals negative 11. And so that is that equation in standard form. This is the equation in slope-intercept. Well, I found the y-intercept, it was 11. I already wrote it in slope-intercept form, but we'll do it again just for the fun of it. So now number 3 wants an equation in slope-intercept form for this function in this table. So the first thing I need to do is find the slope of the line. I'm going to have to know it if I want to write an equation. So for the slope of a line, I got to find my change from 1.3 to 2.5. I just take my calculator out and I subtract, and I get that that is adding 1.2. So those numbers are getting bigger. And my change from negative 2 to negative 1 is also plus 1. So that makes my slope 1.2. Well, if I want to convert that to a fraction, because fractions are so much more helpful when I'm doing slope, that's going to be 6/5. You don't have to use the 6/5. I'm just telling you, if we're going to graph it, that would be helpful. Now we need the y-intercept, and there are a couple ways to do this, but they made it super easy on us because they put it in our table. It's right here where x equals 0. My y-intercept is 3.7. So now I have slope and I have y-intercept, and I'm just going to keep everything. I'm going to use the fraction, but you could use the decimal too. So I have y equals 6/5 x, because that's my slope, plus 3.7. Now I'm going to leave my y-intercept as a decimal because that's a little bit easier to graph, but to use slope, the ratio or the fraction is usually better, so you have rise over run. So let's do number 4. I don't know why there's a random number 6 here. We want to write an equation in standard form for the function in this table. So step 1, we need the slope. So let's find the slope of this line. So from negative 13 to negative 10 is adding 3. And from 5 to 10 is adding 5. So my slope is going to be 3/5. My y-intercept, it's not there. And so what we're going to do, since I don't happen to know the y-intercept off the top of my head, is we're going to go to point slope form, because if I look at this table, I have not 1, but 3 different points. I've got this point, and this point, and I can plug any of those points into point slope form and then use that to solve my equation. So that's what we're going to do. So in point slope form, I'm just going to use this first point right here, this 5, negative 13. So I'm going to do y minus negative 13, so it becomes plus 13, equals your slope 3/5 times x minus your x1, so x minus 5. So we'll distribute. So I have y plus 13 equals 3/5 x. And when I do 3/5 times 5, the 5's cancel, leaving me with just a 3. So let's get this in standard form. So I'll subtract 13 from both sides, so the y is by itself. And so I have y is equal to 3/5 x minus 16, and I have run out of room to write now. So I'll try to squish it over here. I need x and y to end up on the same side, but I also need to get rid of a fraction. And so Ellie and I were working a problem in class today, and it was like this, and we need it in standard form. And I asked her what she should do first, and she was like, well, let's get rid of the fraction first. And after we worked that problem, I decided that was way easier than my way. So we're going to do it Ellie's way. We're going to clear our fraction first, because standard form can't have fractions. So I'm going to multiply this whole thing by 5. When I do, this 5 will cancel, but nothing else will. So I have to multiply everything else by 5. So this becomes 5y equals, then this becomes 3x because my 5 canceled, minus, and I have to do 16 times 5, which is 80. So I end up with minus 80. Well, now I've got to get my x over there with my y, which means I'm going to have to subtract 3x on both sides. So I'm going to end up with negative 3x plus 5y equals negative 80. But that's not standard form either because I have a negative in front of the term with the x. So now I have to change all my signs because I have to multiply everything by negative 1. And again, I have run out of room, so I'm going to write it up here at the top. I'm just going to change all the signs. So it's going to become a positive 3x minus 5y equals positive 80. This is standard form. So I multiplied this by negative 1, which changed all of the signs in the problem. So that's standard form right there. I'm sorry it is so cramped and squished. All right, so number 5, we want to write an equation that represents the line that passes through those 2 points in slope-intercept form. Well, you got a couple of options. First of all, I recognize that this point right here is my y-intercept because x is 0. So I have my b. All I need to write an equation in slope-intercept form is slope. So we're going to use our 2 points and find the slope using that pretty formula that we learned before. I don't want that to be y equals. I want that to be m. So we're going to erase. So I want to find the slope, and I'm just going to find the slope by subtracting my y's and over subtracting my x's. So I'm going to do 6 minus 2 over 2 minus 0. So I subtracted y's, subtracted x's. Well, 6 minus 2 is 4. 2 minus 0 is 2, so that becomes 2. So my slope is 2, my y-intercept is 2, so my equation in slope-intercept form is y equals mx plus b. That's slope-intercept form. So that one was pretty easy. Number 7, on the other hand, is not so easy. Okay, they ask us to write an equation that includes those 2 points, and they want it in standard form. Well, you have a couple of options. You can make a table here, so we can find the slope pretty easy. Or we can find the slope like we just did. I'm going to, first of all, see if I can fix this so that I have a little more space to write. Well, since I don't have a whole lot of room to write, I'm going to go to a blank page so that I have plenty of room to do this problem. You can put yours, add an extra sheet of paper, but I'm going to write these 2 points on a blank page over here. So I'm going to insert a blank page. And so my points are 8 and negative 2 and 4 and negative 4. So I'm going to go over here. I have 8 and negative 2, and then also have 4 and negative 4. I'm going to make a table out of these values is what I'm going to do. I have my x's and my y's. So I have this point 8 negative 2, and I have this point 4 negative 4. And from a table, I can pretty much find what I need to know. Let's find the slope. So the change from here to here is negative 2, and the change from here to here is negative 4 because they are both getting smaller. So my slope becomes negative 2 over negative 4. The negatives will cancel each other, and 2/4 simplifies to 1/2. So there's my slope. So I have a slope of 1/2. Now what I have to do is find my y-intercept. So I don't have it in my table. So I'm going to use my point slope form so I can write my equation. And it says that I need that equation to be in standard form. So I'm going to go to standard form from here. So I'm going to start with point slope, and I'm just going to use this first point, this 8 negative 2. So I end up with y plus y1, or minus y1, so it becomes y plus 2 since y was negative, equals my slope 1/2 times x minus 8 because that's my x value. We'll distribute, so I have y plus 2 equals 1/2 x minus 4. Half of 8 is 4. And then I'm going to subtract 2 from both sides. So I have y equals 1/2 x minus 6. And like I did in the last problem, I told you, Ellie showed me this, made this easier for me. I know I need standard form. Since I got to be in standard form, it means no fractions. So I'm going to clear my fraction by multiplying this entire thing by 2. So 2 times y becomes 2y. That cancels out this 2, so I have 1x left. And then 6 times 2 is 12. So this is what I have. Well, I'm still not standard form because this x has to be over here with the y, so I would subtract x on both sides. So I would have negative x plus 2y equals negative 12. And because this number can't be negative, I would multiply the whole thing by negative 1, which would change all my signs. So standard form would be x minus 2y equals 12. And that would be my answer in standard form for that number. So over here, this would be x minus 2y equals 12. And all my work was on the other page there. So number 8. Number 8 says the number of shirts you buy at the store determines the amount of money M you have in your wallet. This table represents the amount of money left after different amounts of shirts are purchased. I think that my table happens to be over here, and so it's not that the problem and the thing aren't on the same page. I apologize for that. That should not have happened. So we're going to go on the back. Using this table, we're going to find the slope. So the first thing we're going to do is find our change. So my change from 170 to 125 is 45, and since they're getting smaller, it's negative 45 because it's the amount of money I have left. And then from 2 to 5 is plus 3. So my slope happens to be negative 45 over 3, and if I simplify that, it becomes negative 15. And so what that means is that it means that since this is negative, every time I buy a shirt, I am spending $15. So because to find the amount of money I have left, I have to take out $15. So the meaning of this slope is that each shirt costs me $15. So every time I buy a shirt, I'm spending $15. I apologize for that. So that tells me that each shirt is $15. So now I got to write an equation in slope-intercept form in terms of S and M that represents the data because these are my variables. Well, S happens to be my independent variable, so that's X. My money left is my dependent variable, so that's going to be Y. So I'm going to use them in the same place, but I'm going to use the letters S and M. So instead of X and Y, I will use the letters S and M, okay? So when I write my equation, I'm going to use point-slope form, but I'm going to use the letter M for Y and the letter S for X. So for my Y's, I would have M minus the first, my point right here. Oh, we'll even go with it actually really doesn't matter. I'm going to go with this bottom point, this 1220, and so my M happens to be 20, so I have M minus 20 equals, my slope is negative 15 times S minus 12, because that's the S value that goes with my 20. And then I'm going to do the math, so I'm going to distribute M minus 20 is equal to negative 15S plus, because this negative and this negative, when I multiply, will become positive. And 15 times 12 is 180. And I need this in slope-intercept form, so I want this M, which is the same thing as my Y by itself, so I'm going to add 20. And so what I end up with is that M is equal to negative 15S plus 200, because 180 plus 20 is 200. So there's my equation in terms of M and S in slope-intercept form. So the next question asks for the domain and range of this situation. Well, we're just going to go with what's in our table, because we're going to assume that that's the information that we have. And so my domain is the number of shirts, because that's what goes with my X values. And that would be 2, 5, 7, and 12. We're going to assume, based on the data that we are given, that nobody bought 3 shirts or 4 shirts or 8 shirts. Those are the numbers of shirts that got bought, which makes my range, my M values, the amount of money left, and it has to go in order least to greatest, so this time it would be 20, 95, 125, and 170, and that would be my range, and just based on the data that I was given. So last question asks, how many shirts do I need in order to have $50 left? Well, here's my equation. I want $50 left. Well, the amount of money left is M, so I want M to be 50. I want to find out what S is, and so I'm going to plug it into my equation. Well, I'm going to solve my equation. I would subtract 200 on both sides, so I would get negative 150 is equal to negative 15S. And then I would divide both sides by negative 15, and when I do negative 150 divided by negative 15, I get positive 10 equals S. So I would have to buy 10 shirts if I wanted to have $50 left. Or, I mean, I could buy 10 shirts. So 2 more questions. Number 9, a video store is having a sale on a certain kind of movie. At the end of the first day, the store had 250 copies. At the end of the 4th day, there were 130. Write an equation that models the sale of this movie when D is days and M is movie. So the first thing I'm going to do is I'm going to make a table. And I'm going to think about what's independent and what's dependent. So the number of days and the number of movies. Well, the number of movies I have left depends on how many days I've been selling. Okay? So m is my dependent, d is my independent, so that makes d my x and m my y. So I'm going to plug in what I know. At the end of the first day, so that's day 1, there were 250 movies. At the end of the 4th day, day 4, there were 130. If I want an equation, I can't do anything without a slope, so I'm going to find my slope, change in y here, is negative 120, because those numbers are getting smaller, and my change in x is going to be plus 3, and so when I divide that, I get that my slope happens to be negative 40. That's my slope. I'm not going to use the letter m to represent it because I'm using m for something else in my problem. So my slope is negative 40. Now what I need is my y-intercept. So I'm going to go back to my point slope form and I'm going to pick a point. We'll use this first one. Y minus 250, because that's my, and we're not going to use y, we're going to use m and d. We're going to do like we did on the last problem. So instead of y and x, we'll use m and d. So I'm going to have m minus 250, so that's my first m value, is equal to my slope, negative 40, times d minus 1. And we'll just do our math. So I end up with m minus 250 is equal to negative 40d. Does that mean, and what this means is that they are selling 40, let me say that really hick-like, they are selling 40 of these movies every day. The negative means they're selling them, so they have less of them. The 40 tells me how many a day. And then when I do negative 40 times negative 1, it becomes plus 40. And so I want m by itself because we're going to go ahead and get this in slope-intercept form. So I would add 250, so m would equal negative 40d plus 290, because I added 250 to both sides. And so there's my equation. And what I know from this equation is that they're selling 40 videos a day, and they started out with 290 of them. So last one. They want an equation of a line in standard form given the x-intercept and the y-intercept. Please remember that the x-intercept is a point. It is the point 4, 0 in this case. And the y-intercept is also a point. In this case, it is 0, negative 2. Well, the first thing I need to do is find the slope. Make a table, x, y values. Let's plug them in. I have 4, 0, and 0, negative 2. So let's use that table to find our slope. That change is negative 2. This change is positive 4. So my slope is negative 2 over 4, which is negative 1/2. So there's my slope. And guess what? They gave me the y-intercept. They said right here the y-intercept is negative 2. So my equation, in slope-intercept form anyway, is y equals negative 1/2 x minus 2. But that's not what they asked for. It says right here that they want it in standard form. So I got to get all my fractions out of the way and x and y on the same side. So let's get rid of the fraction first. We're going to do it the Ellie way. We're going to multiply everything by 2. So the fraction goes away. 2 times y is 2y. This 2 cancels, so I have negative x. And then this becomes 2 times 2 is 4, so minus 4. Well, I need x and y on the same side to be in standard form, so I would add x. So this would become x plus 2y equals negative 4. No fractions, no negative in front of the x. That's standard form. So there's how you solve that. So that's equations with a table and 2 points. It's very similar to what we've been doing. We just go back to that point slope form. It's good practice to have. We will practice this when you come to class tomorrow. I will see you then.